Hi students, this section is functions and relations. So this page here, we're working with identifying functions. Again, please write down all these definitions, examples, and work shown for your notes. So when we're identifying functions, with functions, for every input, there corresponds exactly one output. So input and outputs. However, there are rules with functions that associate more than one output with an input. So here's an example of this rule I just mentioned. If you had, for instance, x equals y squared, and you had an input of x equals 4, the output y could equal 2 or negative 2. Because if you think about it, if I had 2 squared, that equals 4. And if I had negative 2 squared, that also equals 4. So this example right here is where you have more than one output for this example. And as this mentions below, this example of the input having more than one output, this is an example of a relation. So here we have our first example for this section. It says decide whether the relation is a function. Remember, a function has to have one input and one output. If it does not have one input and one output, then we can call that a relation. So it's saying decide whether the relation is a function. If so, give the domain and the range. Domain is representing your x values, and the range is representing your y values. So let's look here at example A. We have for our input 1, 2, 3, 4. Output is 2, 4, and 5. Is that a function? Is there one input for one output? And the answer to that is yes. For every input, there is one output. If we look at B here, notice we have our input 1, 2, 3, 4, output 5, 7, 9. Notice the 1 value right here goes to both 5 and 7. So for B, that is not a function. So if we look at the answer here, it says for A, the relation is a function. For each input, there's exactly one output. But for B, this is not a function because with our input value of 1, there has two outputs, one at 5 and one at 7. So since A is a function right here, we have to state our domain. Our domain is our x values. So our domain is going to be 1, 2, 3, and 4. Our range values are going to be 2, 4, and 5. Next, what we're going to look into here is identifying functions looking at graphs. So when you graph a relation, the input is given by the horizontal axis, and the output is given by the vertical axis. And the graphs below are showing how to showing how these represent a function by using the vertical line test. So a relation is a function of the horizontal axis variable if and only if no vertical line passes through 2 or more points on the graph. So for instance, if we look at the first graph right here, notice here is our graph, the V. The red dotted line going through, this is what we call the vertical line test. And notice it passes that graph only once. So this is considered a function because it goes through the graph only once using the vertical line test. The next graph here, this is also a function because notice my vertical line test, it passes that graph only once. So that represents a function. Whereas the last two graphs that we have, when we use the vertical line test, it passes through that graph twice. So that is not a function right there. So that's how you can determine, looking at graphs, if it is a function by using that vertical line test. So with functions and relations, we're going to work with something a little new here too, where it says working with function notation, that is written in the form of f of x. And this f of x replaces the y in an equation. So here I have an example showing this to you. Example number 2, evaluate the function for the given value or the variable. So here, notice it's f of x. We're used to seeing y equals 2x minus 3. But now with function notation, we're replacing that y with f of x. F of x represents the y. What you have here is 2x minus 3, and we're going to substitute. They're saying x equals negative 2. We're going to substitute negative 2 in for x. So what we have is f of x equals 2 times negative 2 minus 3. Negative 2 times 2 gives me negative 4 minus 3. So my f of x is going to give me negative 4 minus 3 is going to give me negative 7. The last example right here, it says graph of a function. Since the function notation allows you to write f of x in one place of y, the graph of a function can now be written like the following, where you have f of x equals negative 1/2 x plus 3. So we're used to seeing y, we've replaced it with f of x. So we're going to graph f of x equals negative 1/2 x plus 3 on the graph. Remember, this plus 3 is my starting point. That is my b, my y-intercept. That is the starting place on my graph. So I'm going to go up on the y-axis at positive 3. And then negative 1/2 x, this is representing my slope, my m, my rise over run. So I'm going to go down 1 and to the right 2. Go down 1 and to the right 2. I could also even go from the starting point up 1 and to the left 2. Use your straight edge and you're going to connect those points. And this line right here represents this function, this graph, this function of f of x equals negative 1/2 x plus 3.